radicals. And this is the test review. This is the second objective. This is working with rational exponents. Now, if you've already done it all and you want to just pause and check it without hearing me blather on, feel free to do that and then cancel out the video. Or I'll explain how to do each one. Up here, this first one, write each expression using a radical symbol. Key right here, radical symbol. Remember that if you have x to the m over n, m is the power, n is the index. So you have the nth root of x to the m. Now, in this particular situation, I'm not asking you to simplify anything. Just rewrite it using a radical. Now, in this case, we have, a binomial. We have that binomial. Okay, you don't need to multiply it out to the fifth power, and you cannot ever just distribute a power over terms, over things that are being added or subtracted. Remember, when you had x plus 5 quantity squared, x squared plus 25, it was not. This would mean to FOIL. This m plus n to the fifth means doing m plus n times m plus n all the way out until you have 5 of those. So you can't just put the 5 on. But you can keep it all inside the parentheses, raise to the fifth power, and put the 7 in the index location. Okay, that's all you have to do. For this one, all right, you need the 11th root of 1 over z squared. Again, the negative says it goes in the denominator, so I want to get rid of the negative, but you don't have to rationalize this. I'm not asking you to do that, so this should take just a second. Now, write each expression using an exponent. Again, over here we have the 8th root of 5. This is 5 to the first power. 5 is a prime number, so I can't do anything else with it. So the 8 goes to the denominator, 1 goes to the numerator. Pretty basic there. 1 over the 17th root of k cubed. Again, remember when I bring k up, that's that negative. That negative is what tells me it goes in the denominator. 3 is the power, 17 is the denominator. That's it, just rewriting, no simplifying. Now, evaluating each expression, no decimals. When you have 64 to the 2/3, I don't want to square 64. It's much easier to take the cube root of 64. By now you should all know that that's equal to 4. Then I can take 4 and square it and get 16. Much simpler process, no calculator needed. The next one, pay attention to what you've got here. 125 to the negative 2/3. That means you've got 1 over the cube root of 125, and then you're going to square that. The cube root of 125 is 5. 5 squared is 25, 1/25. That negative does not make the answer negative. It does the reciprocal. Then, over here, we have negative 8 to the 4/3. This is the tricky one. Tricky. This is the same thing as negative 1 times 8 to the 4/3. That's not negative 8. It's not in parentheses. When it's not in parentheses, the negative indicates it's negative 1 times. So now I have negative 1 times the cube root of 8 to the 4th. Negative 1 times 2 to the 4th is negative 1 times 16 is negative 16. If this had parentheses like this, then it would be positive 16. But the parentheses are not there. Therefore, the power does not extend to the negative. Beware. Pay attention. Make sure you know how to do that. Okay, simplest radical form. The fourth root of 121. 121, I don't know what the fourth root is, but I do know that I can rewrite 121 as 11 squared. And you're like, well, that doesn't help. But then if I write 11 to the 2/4 power, I change it to an exponent. Then I can simplify my exponent to 1/2, which then means I can simplify my radical to just square root of 11. There is one, like all of these on your test, you just have to know the process. Okay, when you've got something like this, see if you can write it to another power, and then can you simplify that power. Simplest radical form, and you've got exponents, you need like denominators. Why like denominators? Because you need one index. Okay, so 2/3, if I have p to the 2/3 r to the 3/8. Like denominator between 3 and 8 is 24. So I'm going to multiply this by 3 over 3 and this by 8 over 8. That's how I get p to the 16 over 24, r to the 9 over 24. Now that the index is the same, I can do one radical, the 24th root of p to the 16th power, r to the 9th power. You need like denominators so that you will have a single index. That's your key. All right. Finally, this should be the easy one. Okay, the 7th root of the 8th root of 29. Just multiply the indices. And if that confuses you some, remember that this is 29 to the 1/8 to the 1/7. And what do you do when you raise a power to a power? You multiply. So then you get 29 to the 1/56. Simplest radical form says there's a radical in it, so it's the 56th root of 29. Don't know what that is, but that's the simplest radical form. All right, you're good to go on Objective 2 for Unit 6.